Hello everyone, welcome back to the session. My name is Abhishek and I am mathematics faculty here at AskIITians. So this is chapter mensuration which we are doing, and this is the last lecture, that is lecture number 5 of this particular chapter. In this lecture, we will be studying some advanced concept, or you can say some topics which will be important for your Olympiad specifically. Okay. So before we delve into the topics, it's important to understand the weightage of this chapter, both for school examination and board Olympiad examination. So if you talk about school examination, you can expect questions carrying around 11 marks from this particular chapter. 11 marks means you can expect around 3 to 4 questions from this. Okay, 3 to 4 questions can be expected in your school examination from this particular chapter. And if you talk about Olympiad examination, in Olympiad examination, you can expect around 3 to 4 questions from this chapter, which is quite high. Okay, so do not ignore this chapter. And if I talk about the relevance of this chapter for your senior classes or for your 9th and 10th class, this chapter is very, very important for your 9th class as well as 10th class. In both the classes, you will come across mensuration once again. So it's best if you can actually grasp this particular chapter here, so that it becomes easy for you to actually grasp the concept in your higher classes and perform excellently in this particular chapter. So let's start with the topics. So here the topics that we are going to cover is we are going to discuss about hollow shapes and shells. Okay. For example, if you see this figure here, this is hollow from inside, right or not? This figure, if you see properly, this is hollow from inside. So we are going to study about such figures. We are going to study how we can calculate the surface area of the figures like this. We are going to discuss how the volume of the figures like this can be calculated quite easily. So all these things we are going to discuss in this particular topic. It's super easy. It's related to the topics that we have already covered. It's just that you have to be a little attentive while we discuss it. That's it. Okay. So let's start what we have. Okay. And here, before I begin with the topic, I would like to tell you one important thing here. This figure, which you can see, this is, you can say, that's a hollow hemisphere, you can say, right? So this part that you have, this is the outer part, right or not? This is the outer part of the surface of this hemispherical hollow hemisphere that you have, hemispheric. And if you talk about this part, then this is the inner part of this hemispherical hollow hemisphere that you have. And we will like very frequently come across these terms, like whenever you are talking about hollow shapes or shells, then it will always have two parts. One part will be the outer part, the other part is always going to be the inner part. So be very like, it should be very, very clear to you guys what we are talking about. Understood? So here we have introduction to hollow shapes and cells. The first topic we have is right circular hollow cylinder. That is, we are talking about cylindrical shell. We all know what is cylinder, right? We studied what are the properties of cylinder, and as far as cylinder is concerned, what is the formula for the curved surface area of cylinder? What is the formula for the total surface area of the cylinder? And not only formulas, we also discussed what is the meaning of these things, right? So here we are discussing right circular hollow cylinder, or you can say cylindrical shell. And whenever we are talking about right circular hollow cylinder or cylindrical shell, that means we need to have two cylinder, or if I have to call you can say we need to have two concentric cylinders, means which the cylinders which have the same axis. All right. So this is the inner cylinder that you have. Okay. This is the inner cylinder that you have. Clear? That pink one. And if you talk about this one, this is the outer cylinder that you have. Outer cylinder that you have. And this portion, which is actually in blue color. Okay. This is the only solid part that you have here. This is the only solid part that we will have in this figure. And this part that you have here in between, this is the hollow part. Hollow part. Okay, right? Similarly, if you look at this second figure, this is the outer part. I am writing OP. This is the inner cylinder that you have. Okay, inner part you can say. This is the solid part, or whenever we will talk about the volume of the material that is used to form this figure, that means we will be talking about the volume of this portion, which I have shaded in red color. Okay, and similarly, we have this last also. Here you can say this is the outer part or the outer cylinder that you have. This is the inner cylinder that you have. Okay, this is the solid part that you have, and this is the hollow part that you have in between. Clear? So that means when you have two cylinders which are put together in such a way that they have same height, they will have same radius and same axis, then what the figure that we get as a result, that is called hollow cylinder or cylindrical shell, provided the smaller cylinder that you have. When I say smaller cylinder, that means I'm talking about cylinder with a small radius. That smaller cylinder should lie inside, and also it should be hollow from inside. So that is what give rise to hollow cylinder or cylindrical shell. Now what does it say? It says if let's say the outer radius is capital R, so they have denoted this outer radius by capital R. Inner radius is a small r, they have denoted this as inner radius by small r. Then when they are asking you about the volume, so first we will discuss about volume. When they are asking you about the volume, means they are asking you about the volume of the material that is used to form this hollow cylinder or the cylindrical shell that we have with us. I repeat, when they ask you about the volume of the cylindrical shell, then indirectly they are saying, please find out the volume of the material that is used to form this cylindrical shell. And when you have to form the volume of the material, or when you have to find out the volume of the material that is used to form this cylindrical shell, what you have to do is you have to subtract the volume of smaller cylinder or inner cylinder from the volume of the bigger cylinder or the outer cylinder. So if you are talking about volume, then what will be the volume? Volume of outer cylinder, I am writing volume of outer cylinder minus volume of inner cylinder. If you subtract those two, you get the volume of the material that is used. The volume of the cylinder, we know the formula for the volume of the cylinder, that is pi r square h. It's just that the radius will change when we are talking about two cylinders. The height is going to remain intact. So volume of outer cylinder will be pi capital R square small h. Volume of inner cylinder will be pi small r square h. Okay, you can take pi h common from both of them. So if you take pi h common, what will you get? You will be getting capital R square minus small r square. Here you can also use the identity of a square minus b square. If you use a square minus b square, you will get pi h capital R minus small r multiplied to capital R plus small r. So this is the formula for the volume that we have got. Okay, or you can say this is the volume of the material that will be used to form this hollow cylinder or cylindrical shell. Is that clear? Now, when we are talking about total surface area of cylindrical shell, this first part, this is very important and interesting. So let me use another color to discuss this. One second. Let's go ahead with the red color. Okay, so when we are talking about total surface area of cylindrical shell, see, if I have to tell you in layman's term, what is the meaning of total surface area? Total surface area means, let's say I provide you this hollow cylinder, okay, or cylindrical shell is provided to you from my side. Then you have to find out the area of the entire portion which you can touch in this hollow cylinder or cylindrical shell. The portion that you can touch in this hollow cylinder or cylindrical shell, that portion, like the area of that portion, is what we are interested in. And if you talk about this hollow cylinder, then in hollow cylinder, when you are talking about total surface area, in that we are going to include cut surface area of outer cylinder, right? Plus you are going to include cut surface area of inner cylinder, right? As well as we are going to include the area of this reddish part as well. Okay, the area between the two concentric circles that we will have. So that will be given by pi capital R square minus small r square. Since we have two figures or two portions like this, it needs to be multiplied to 2. So if you talk about the curved surface area of the outer cylinder, it will be given by 2 pi capital R. Okay, because capital R is the radius of outer cylinder multiplied by small h. Curved surface area of inner cylinder will be 2 pi small r multiplied by small h. And the area of that reddish part which you have at the top and the bottom, that will be given by 2 pi capital R square minus small r square. So this will be the total surface area of the cylindrical shell. And here one more thing should be very clear to you. If they are saying that please find out the curved surface area of the cylindrical shell, then you need to calculate the curved surface area of the outer part as well as the inner part. Let me tell you that, or let me write that third point here. If they are saying curved surface area of cylindrical shell, okay, then that will be equal to what? That will be equals to curved surface area of outer cylinder that you have, and to that you need to add curved surface area of inner cylinder. Okay, when you add both of them, you get the curved surface area of the cylindrical shell which is in front of you. I hope the meaning of cylindrical shell or hollow cylinder, that's very clear to you. Apart from that, like what's the meaning of volume of cylindrical shell that we have, that's very clear to you. The total surface area is clear to you. The curved surface area is clear to you. Please go through it before we move to the next slide and take few problems based on it. Is it done? Done? All right. So here we have a problem or the application of the thing that we discussed just now. Okay. What does it say is Elsa goes to a shop to buy a cylindrical pencil box. So this is the pencil box that we have here. Pencil box. It looks good. The outside of the pencil box is made up of radius of 4 inches. So basically, okay, and the inside is made of sponge of radius 2 inches. The height of the box is given as 20 inches. Help Elsa figure out the total surface area of the pencil box. So this is interesting problem. This is a pencil box you have. Okay, this is a pencil box. All right, this is the zip you have. So what does it say? It says the outside of the pencil box is made of a radius of 4 inches. The inside is made up of a sponge with radius 2 inches, and the height of the box is given to be 20 inches. All right. So here, what do we need to calculate? We need to calculate TSA or total surface area of this pencil box. So TSA of pencil box, if you have to calculate, which portion are we going to calculate? Check out. Okay. See, this pencil box that you have here, it is closed from this side, correct? It is closed from that side as well. Okay. So that means when we will be calculating the area of these two circular portions that we have on the extreme left and the right hand side, that means we have to just calculate the area of circle. So if you talk about total surface area of pencil box, for that I need to calculate the curved surface area of the outer cylinder that I have. Okay. To that I need to add the curved surface area of inner cylinder that I'm going to have, right or not, because we can touch it from inside as well. And we need to add the area of these two circular parts that we have. So that will be 2 pi capital R square h, where capital R will be the radius of the outer part. So if you talk about curved surface area of the outer part, what will you get? You will be getting 2 pi capital R h. Okay. If you talk about curved surface area of inner part, you will be having 2 pi small r h. Only the radius will change. And if you talk about the area of the circular parts that you will have, you will be getting 2 pi capital R square h. Clear? That's what we have. 2 pi capital R square, sorry, not h. All right. Now all we have to do is we have to put the value in it. And if we put the value in it, I will get my answer. That's it. Check out. So I can take 2 pi h common, 2 pi common from all of them. So I'll be getting 2 pi. Inside bracket I will have capital RH, small rh, and this is capital R square. Capital R is given 4. Okay, so you have 2 into 22 by 7. Capital R is 4, height is given 20. Okay, small r is given 2, height is given 20, and capital R is 4, so that will be 4 square, correct? If you simplify this here, you will be getting 44 by 7. If you simplify it, you will be getting 80. This will be 40, and that is going to become 16. 80 plus 40 is 120, and 120 plus 16 is 136. So what will you get? You will get 44 upon 7 into 136. Now, please multiply 44 and 136 quickly and let me know what you are getting. If you multiply 44 and 136, what will you get? You will be getting 5984. Okay, so you will be getting 5984 upon 7. And if this 5984 is divided by 7, what do you get? You will be getting 854. Approximately, you will be getting 854.85 inch square. Okay, so that is the like total surface area of the pencil box which Elsa went to buy to the shop. I hope it's very clear to all. What we did here, like to calculate the total surface area of this pencil box which you have, what we did is we calculated the curved surface area of outer cylinder because we can touch it, curved surface area of inner cylinder because if you open the zip you can touch that part as well, and we have two circular ends also. So we calculated the area of those two ends. We just added all the values and got our answer. Please go through it and ask me if you have any query or doubt in it. Done? All right. Here, it should not be cylindrical shell because when you are talking about cylindrical pencil box, okay, then this is not open from here. Okay, that's what we are assuming. After that, we have hollow sphere or spherical shell, guys. Okay, hollow sphere or spherical shell. So if you talk about hollow sphere or spherical shell, it's very, very similar. Okay, you must have seen football. You must have seen cricket ball, leather cricket ball. Okay. In fact, you can see this figure in front of you. This is a hollow sphere that you have. This is the inner part of this sphere, hollow sphere you have, spherical shell. That is the outer part you have. Okay. So it also comprises of inner part and the outer part. And if I assume the radius of the outer part to be capital R and the radius of inner part to be capital R, then the volume is given by the volume of the bigger sphere that you have minus volume of the smaller sphere. So if you talk about volume, that is given by volume of outer sphere minus volume of inner sphere. Okay. And volume of outer sphere is given by 4 upon 3 pi capital R cube. Volume of inner sphere is given by 4 upon 3 pi small r cube. Okay, you can take 4 upon 3 pi common from both of them. If you take 4 upon 3 pi common from both of them, you will be getting capital R cube minus small r cube from it, right? So that is the formula you have for the volume of a spherical shell. If you talk about the total surface area, okay, then total surface area will be what? The total surface area that we have here, because that's a hollow sphere, so here it should be positive sign actually. Okay, then that is the surface area of the outer sphere plus surface area of the inner sphere. So you will have surface area of outer part plus you are going to have surface area of inner part. So surface area of outer part will be 4 pi capital R square and surface area of inner part will be 4 pi small r square. So you can take 4 pi common. If you take 4 pi common, you will be getting capital R square plus a small r square. That gives you the total surface area of the spherical of the spherical shell that you have, or this hollow sphere which is given to you. Clear? Done? All right, so here what do we have? We have a problem based on this concept. It says water is being poured into a hollow sphere of outer radius this and inner radius this at the speed of 10 centimeter cube per second, and we have to find out the time that would be required to fill this hollow sphere. So because we have to find out the time that is needed to fill this hollow sphere, so for that first we need to calculate the volume of this hollow sphere. Okay, so if you talk about volume of this hollow sphere, okay, then volume of this hollow sphere will be given by volume of outer sphere, okay, outer sphere minus volume of inner sphere. Clear? That's what you have. Now what is the volume of outer sphere? The volume of outer sphere is 4/3 pi capital R cube minus volume of inner sphere will be 4/3 pi small r cube. Clear? So you will be getting, you can take 4/3 pi common, you can substitute the value of capital R and small r. Capital R is 10, small r is 5. Clear? So we will be getting 4/3 into 22/7, and here what will you get? You will get 1000 minus 125. So when from 1000 you subtract 125, what do you get? You subtract 125, you get 875. So you have 4/3 into 22/7 into 875. Now the thing is, can we actually divide this 875/7? Let us see. 7 1 is 7, you will be getting 1 7, 7 2 is 14, 3 5. We can certainly cancel it. So you will be getting 1, you will be getting 2, you will be getting 5. Okay, that's what you will get. Now I don't think we can cancel anything else. Please multiply and simplify what you are getting. You have to multiply 4 to 22. You have to multiply 4 to 22, and that needs to be multiplied to 125, guys. So what will you get if you multiply 4 to 125 and that is multiplied to 22? You will be getting around 11,000. Okay, so you will be having 11,000 upon 3. Okay, that is the volume you are going to get, centimeter cube. Correct? Now what is given? We are provided the speed of water pouring. Okay, speed of pouring of water. What is that? That is 10 centimeter cube per second. Pouring of water, that is 10 centimeter cube per second. Okay, so if you want to find out the total time that would be taken to fill this sphere, how will you calculate? Therefore total time taken, that will be given by 11,000 upon 3 into 10. So this 10 will cancel it, like 1 0 will get cancelled. So you have 1100 over 3. If you divide 1100, okay, by 3, what will you get? If you divide 1100 by 3, you will be getting approximately 367 seconds. Okay, if you want, you can convert it into a minute as well, or in hours as per your choice. Is that clear? So what we did here, we were supposed to find out the time that would be taken to fill this hollow sphere. So what we did, we first calculated the volume of this hollow sphere. For that, we need to subtract the volume of inner sphere from the volume of outer sphere. Volume of outer sphere will be given by 4/3 pi capital R cube. Inner sphere 4/3 pi small r cube. Capital R is 10 centimeter, small r is 5 centimeter. We are provided. We substituted capital, like 10 cube is 1000, 5 cube is 125 that you have, right? You have 5 cube as 125. So if from 1000, 125 is subtracted, what do you get? You get 875, right? And if you subtract 875 by 7, what do you get? You get 125. And when this 125 is multiplied to 88, you get 11,000. And when this 11,000 is divided by 10, that's what you get. Okay, so around 367 seconds would be needed to fill this hollow sphere. I hope that's very, very clear to all of you. Done. Okay. So here, what they did, they also did it in the same way. It's just that they have taken pi to be 3.14. Okay. They have taken pi to be 3.14. So if it is not mentioned that you have to go ahead with pi as 3.14, you can choose pi as 22/7. Like there will not be any issue, or your marks will not be deducted because of that. Because they have chosen pi to be 3.14, that's why you are seeing little variation in the answer, but both are absolutely correct, because it was not mentioned anywhere in this problem that I have to go ahead with pi is equal to 3.14. Apart from that, if you look at the solution, the entire approach is same. Outer radius was 10 centimeter, inner radius was 5 centimeter. They calculated the volume of hollow sphere by using this formula, 4/3 pi capital R cube minus a small r cube, that we discussed just now. After solving it, they got 3500 centimeter cube, and the rate at which water is being poured, that is given to you, that is 10 centimeter cube per second. So if we have to find out the total time that would be taken to fill, it would be 3500 over 10, that is nothing but 350 seconds. That is the answer. Because pi was 3.14 here, that's a little variation. Otherwise, both approach are absolutely correct. No marks will be deducted, so don't worry about that. If they mention, please choose pi as 3.14, then please stick to that. Done. All right, so now we have hollow hemisphere or hemispherical shell. This is very similar to the two topics that we covered just now. Okay, a hollow hemisphere has an inner radius and outer radius. So this is a hollow hemispherical shell. This is the outer part you have of this hemispherical shell. Okay, and that is the inner part you have. Okay, that is inner part you have. Clear? So if I assume the outer radius to be R2, the inner radius to be R1, all right, then the volume is given by what? How will you get the volume? If you want to calculate volume, that will be given by the volume of outer hemisphere minus volume of inner hemisphere. Okay, so if you put the value, you will be getting 2/3 pi capital, sorry, R2 cube minus R1 cube, because R2 is the radius of the outer part and R1 is the radius of inner part. This is interesting. If you talk about the total surface area of hemispherical shell that you have, I would say that it comprises of three parts. The first part is it will comprise of the CSA of the outer part. The second thing is it will comprise of the CSA of inner part. And the third part is this reddish part, which I am shading. It will comprise this as well. So you need to calculate the CSA of outer hemisphere. You need to calculate the CSA of inner hemisphere. And you need to calculate the area of this part also, which you have with you guys. So that will be, if you are calculating TSA, what will you have? You will have CSA of outer hemisphere. What will be the value? That will be given by 2 pi capital R square, isn't it? That will be right. So that is the value you will have for the surface area of the outer sphere and hemisphere. The cut surface area of inner hemisphere will be 2 pi capital small r1 square, and the area of this radish part, that will be pi r1 r2 square minus r1 square. Okay, so this value gives you the TSA of this hemispherical shell that you have, or hollow hemisphere. That's it. Clear? All right. So now we have one problem. It says a hemispherical bowl is made of steel 0.25 centimeter thick. The inside radius of the bowl is 5 centimeter. Okay. Then they are asking you find the volume of the steel used in making it. So inside radius is 5 centimeter. That's what we have, guys. So we have inside radius which is equal to 5 centimeters. So let us assume this is the center. So this inside radius is 5 centimeter. What is the thickness? Thickness is 0.25 centimeter. So I am assuming this is the thickness, guys. This is equal to 0.25 centimeter. Okay. So if you talk about the inner radius, okay, the inner radius is equal to 5 centimeter. Inner radius we are going to denote by small r. So inner radius, which is denoted by small r, that is equal to 5 centimeter. If you talk about outer radius, then outer radius will be actually the sum of inner radius plus thickness, right? So inner radius is equal to 5 centimeter we have. So that will be 5. The thickness is 0.25. So you will have 5 plus 0.25, which is equal to 5.25 centimeter. That is the outer radius. So if you want to find out the volume of steel used, what you have to do, you have to calculate the volume of the outer shell, okay, volume of outer hemisphere. From that you need to subtract the volume of inner hemisphere. Okay, so what will you get? You will be getting 2 by 3 pi capital R cube minus a small r cube. Clear? So you will be getting 2 by 3 pi. What is pi? I am using 22 by 7. Capital R is 5.25 cube. Clear? And small r is 5 cube. Is that clear? So it is going to give us 44 upon 21. Okay, please calculate what is the cube of 5.25, guys. What's a cube of 5.25? That will be approximately, I think, 144.703125, and the cube of 5 is 125. Okay, that we all know. So if you do this subtraction, what will you get? If you subtract it, you will be getting, I am writing here, you will be getting V is equal to 44 upon 21 into 144. Sorry, not one. Yeah, you will be getting 144, not 144. 1 second. 144 minus 125. So you will be getting 19. You will be getting 19.703125. That is what you will get. Okay. So you have to multiply 44 to 19.70. You have 19.703125. Okay. And if you divide it by 21, you will be getting, you have, yeah, please solve it. Please solve it. I'm giving you time. 44 multiplied to, yes, 19.703125. Okay. Whatever answer you get, you need to divide it by 21. Okay. So approximately, I think you will be getting 41.2 centimeter cube. Like that will be the volume of the steel that will be used to make this bowl which you have in front of you. So it was not difficult. It's just that they have not given you the outer radius directly. You were supposed to calculate the outer radius using inner radius and the thickness. That would be equal to 5.25 centimeter. And after that, you want to calculate the volume of steel used. So that would be given by the volume of outer hemisphere minus volume of inner hemisphere. So you will have 2 upon 3 pi capital R cube minus small r cube. We know what capital R is. We know what small r is. You just have to substitute the value and solve it. That's it. Clear? This is the answer you have. Okay. You can see it's very close. You have outer radius, they calculated by adding inner radius and the thickness. So they got 5.25 centimeter. Then volume of hemispherical shell would be 2 upon 3 pi capital R cube minus small r cube. So solved it and got the same answer as we got. Clear? Now these two questions that you have, guys, these are for your homework. And the answers are here. You all are requested to first try it yourself. In case you do not get the answer to any of these problems, you can always get in touch with your faculty member or your expert, askIITians expert. He or she will definitely help you out. Okay. And before we wrap up this session, it's quite important for us to revisit the topics that we did or quickly see what all topics we covered in today's session. We discussed about hollow hemisphere, we discussed about hollow sphere, we discussed about hollow cylindrical shell. We discussed 3 topics, I repeat: hollow hemisphere, hollow sphere, hollow cylindrical shell. We did the problems based on that. Now, because this topic is important as far as Olympiad is concerned, it's quite important, I would say. So as far as getting command over this particular topic is concerned, you need to practice a good number of questions. And believe me, if you do that, nobody can stop you from getting a command over this topic. So that is this from this session. Thank you so much for attending this session. Have a great day. Goodbye.